What if there were an alternative to our current nuclear energy setup, one with the benefits of nuclear without the dangers of uranium reactors? The proposed fuel being advocated by a small group of scientists and entrepreneurs is thorium. During the height of the Cold War in the 1960s, Oak Ridge National Lab produced a thorium-based molten salt reactor. However, a nuclear reactor that is unable to produce bomb-grade material made this technology unattractive in a Cold War world. The thorium fuel project was mostly forgotten. Instead, all subsequent nuclear plants were designed to use uranium, the fuel that powers all 104 reactors operating in the U.S. today. There are several advantages of using thorium over uranium as nuclear fuel. First of all, thorium exists in the ground as thorium oxide and is 3 to 4 times as abundant worldwide as uranium, according to a 2005 report from the International Atomic Energy Agency. Secondly, all but a trace of naturally occurring thorium is Th-232, the isotope useful in nuclear reactors, as compared to 3 to 5% of uranium that comes in the form that we need. Thirdly, thorium-based reactors are safer because the reaction can easily be stopped and because the operation does not have to take place under extreme pressures. Unlike U-235, thorium is not fissile. That means no matter how many thorium nuclei you pack together, they will not on their own start splitting apart and exploding. And lastly, compared to uranium reactors, thorium nuclear waste only stays radioactive for 500 years instead of 10,000, and there is 1,000 to 10,000 times less of it to start with. Thorium still holds several disadvantages, first of all being its lack of infrastructure. Uranium-based reactors have been the focus of research, and billions of dollars have been poured into infrastructure that would go to waste if a radical switch were made from uranium to thorium. Secondly, thorium is still radioactive, just not as much as uranium and not as long-lived. Thirdly, using thorium as a nuclear fuel is an area that still needs more research. Thorium reactors are not something that entrepreneurs or even most research companies can afford to pursue, leaving most research opportunities to governments. And lastly, is its general lack of experience dealing with this nuclear fuel. The US has a lot of uranium reactors, engineers are comfortable with them, and it's a mature technology. This is just not the case with thorium reactors. Right now, at least 3 thorium-related bills are making their way through the Capitol, including the Senate's Thorium Energy Independence and Security Act, which will provide $250 million for research at the Department of Energy. Unfortunately, $250 million won't solve the problem. The best available estimates for building even one molten salt reactor run much higher than that. The result is likely that thorium will grow slowly and will take decades to become a significant source of energy, particularly in the US. Emerging nations in Asia appear to be the most likely testing grounds for thorium, and if thorium reaches its potential there, it could easily propel emerging economies to the status of world leaders.